In Lesson 2-4, Example 1, you will be solving equations with variables on both sides. The first thing you're going to want to do to solve 2 plus 5k equals 3k minus 6 is to draw your train tracks. Now, what's different about these equations compared to the ones you've already solved is that we have variables on both sides. We want to start out by either getting rid of this 5k or the 3k. It really doesn't matter which one you choose to get rid of, but sometimes getting rid of one is easier than the other because it'll allow you to work with more positive numbers instead of negative numbers. For example, in this one, rather than getting rid of the 5k, I would probably choose to get rid of the 3k. To completely get rid of 3k, we want to, since this is a positive 3k, we want to subtract 3k. If we subtract 3k from the right, we also need to subtract 3k from the left to keep the two sides equal. When I write minus 3k on this side, I'm going to write it underneath the k's since those are like terms. Now over on the left side, this 2 is still going to be there. And then 5k minus 3k is 2k. And since it's a positive 2k, I'm going to write plus 2k. And on the other side, 3k minus 3k, that is 0k. So I'm not even going to write those down. It's 0. And then we still have a minus 6 or a negative 6. So I'm going to bring that down on the right. Now we have problems that look like ones we solved earlier in the chapter. To get the k by itself, to get a single k, we need to first get rid of this extra stuff over here. We're going to get rid of this 2. To completely eliminate the 2, we want to subtract 2 from both sides. Remember, you have to do the same thing to both sides. Now the 2 minus 2, that's 0, and 0 plus 2k is just 2k. Now over here, negative 6 minus 2, subtraction with negatives, you'll want to change to adding the opposite. Negative 6 plus a negative 2 is a negative 8. Now to get this down to having just 1k instead of 2k, we want to undo the multiplying by 2. So we are going to divide both sides by 2. 2 divided by 2 is 1, and 1 times k is k. And on the other side, negative 8 divided by 2 is going to be a negative 4. Remember, a negative divided by a positive will always be negative. Now to check your solution, you're going to have to plug this negative 4 in on both sides of the equation. So over here on the left, I have 2 plus 5 times a negative 4. We want to see if that's equal to 3 times negative 4 minus 6. Well, following the order of operations, we would do 5 times negative 4 first, which is negative 20. So 2 plus negative 20. 2 plus negative 20 is negative 18. On the other side, we would do 3 times negative 4, which is negative 12, and then minus 6. Negative 12, take away 6 more, is negative 18. That is how we know we've arrived at the correct answer of k equals negative 4. Let's go ahead and try a couple more. In this next example, 3w plus 2 equals 7w. We have variables on both sides. Whenever that happens, we want to get rid of one of them. I could get rid of the 7w, but then I would end up having negative w's over here, and I would have nothing left on this side. So instead, I'm going to get rid of the I'm going to get rid of the 3w by subtracting 3w. So remember, we want to eliminate it completely. 3w minus 3w is 0, and 0 plus 2 is 2. On the other side, 7w minus 3w is 4w. Now we want to end up with just 1w. So to undo this 4 times w, we're going to divide by 4 on the other side as well. 4 divided by 4 is 1, so I have 1w. And on the other side, 2 divided by 4 is 1/2, or 0.5, or 5/10. Now, if you wanted to check this, you'd have to plug 1/2 into both sides. 3 times 1/2 is 1 1/2. 1 1/2 plus 2 is 3 1/2. Over here, 7 times 1/2, or 1/2 of 7, is 3 1/2. It checks out. You may want to pause the video and try the next one on your own. All right, 5a plus 2 equals 6 minus 7a. Draw your train tracks. Now we have variables on both sides again. We either have to get rid of the 5a or get rid of this negative 7a. You can do either one, but I'm going to choose to get rid of this negative 7a by adding 7a to both sides. 5a plus 7a is 12a. You're going to bring this plus 2 all the way down. And then the negative 7a plus 7a, that's going to be 0, and you're left with just 6 on the right. Now to get the a all alone, we need to get rid of this plus 2. We're going to get rid of the plus 2 by subtracting 2 from both sides. Plus 2 minus 2, or a positive 2 and a negative 2, is 0. You have 12a equals 6 minus 2, which is 4. Now we want to divide both sides by 12 to get 1a instead of 12a. So we're going to undo the multiplication by dividing both sides by 12. 12 divided by 12 is 1. 1 times a is just a. And then 4/12, we can just simplify that to being 1/3. Now, if you wanted to check that, you would plug it into both sides and see that you get two things that are equal. All right, this next one has some fractions in it. Go ahead and draw your train tracks. You may want to rewrite this a different way. If there's no number in front of this x, it's really a 1. So another way to write x divided by 2 is 1/2 x plus 1 equals 1/4 x minus 6. That's another way to write this same problem. Now you have variables on both sides. Let's get rid of one of them. I'm going to go ahead and get rid of this 1/4 x. If I want that to be 0, I'm going to have to subtract 1/4 x from both sides. When I subtract 1/4 x, I'm going to subtract it from the x's on the other side. 1/2 x minus 1/4 x. You could rewrite these with common denominators. 2/4 minus 1/4, which is 1/4 x. Bring down the plus 1 so you have your new problem on the left. And on this side, the 1/4 x minus 1/4 x is 0, and 0 minus 6 is -6. Now, to get the x by itself, we need to get rid of the plus 1. We're going to get rid of the plus 1 by adding 1, sorry, not adding, by subtracting 1 from both sides. Plus 1 minus 1, that's going to be 0. And we're left with 1/4 x on the left. And on the right, -6, take away 1 more, or plus a -1. -6 plus a -1, that is going to be -7. Now remember, when you have a fraction attached to the variable, 1/4 times x, to get that to be a 1x, we're going to multiply both sides by the reciprocal. The reciprocal of 1/4, remember, is 4. So 1/4 times 4 is just 1, and 1 times x is just x. And on the other side, -7 times 4 is -28. Now, if you wanted to check this, you would plug it in here. -28 divided by 2. -28 divided by 2 is -14. -14 plus 1 is -13 on the left. And then on the other side, 1/4 times -28, or 1/4 of -28, is a -7. And -7 take away 6 more is -13. So that one checks out as well. Now our last example has some decimals. You have C's on both sides. You're going to either want to get rid of this one or this one. It doesn't really matter which one you get rid of, but if you get rid of the C's on this side, that might be a little more work later, because you would have to then get rid of the 2.8. So why don't we go ahead and get rid of the 3.3C? To get rid of 3.3C, you're going to subtract 3.3C, or 3 3/10 C, from both sides. Remember, you line up the decimal when subtracting decimals. Now 1.3 minus 3.3, that is where you are taking away a larger number from a smaller one. So you may want to change that to adding the opposite. So we know it's going to end up being negative. It's going to end up being negative because this number has the greater absolute value. And we're going to actually subtract these two numbers, and we're going to subtract 3.3 minus 1.3. 3 minus 3 is 0, and 3 minus 1 is 2. Put the decimal straight down. So this side over here is going to be a -2C. And on the right side, we have 2.8. Because the 3.3C minus 3.3C is 0. Now the last thing we need to do is to get 1C, we need to, instead of multiplying by -2, we have to divide by -2. -2 divided by -2 is a +1, and 1 times C is C. On the other side, a positive divided by a negative is always going to be negative, and 2.8, or 2 8/10 divided by 2, is going to be 1.4, or 1 and 4/10. So C equals a negative 1 and 4/10. Again, you can check this out by plugging it back in on the left, seeing what you get. Plug it back in on the right, see what you get, and the two sides should be equal.